And now, Phasors Level 2, where the questions get a little bit more challenging. First question. Drag the black circle to represent blue plus red. And this time, at level 2, the blue and the red phasors on this display here are not in the right positions for these blue and red waveforms. You can move them to the right positions. You don't have to use them at all. They're just there to help. You can drag the black, and there is a dotted waveform display, the dotted grey line here, which will represent the waveform corresponding to this moving black phasor over here. So, we want to drag the black circle to represent blue plus red. Two ways of doing this. We could ignore these blue and red dots on the Argand diagram and just try and do it by looking at this waveform display. Now, we need a waveform here if it's going to be equal to the sum of the blue and the red waveforms, which cuts the blue waveform when the red is 0, because obviously if the red is 0, then the sum of blue plus red must equal blue. So at the time when the red is 0, this waveform here should cut through the blue, like that. And equally, when the blue is 0, the sum will just equal the red, so we'd want a waveform that when the blue is 0 here, cuts through the red waveform, is equal in value to the red. This one clearly doesn't at the moment. Let's move it down a bit like that. And now we're getting somewhere close. About, actually around about there, you could see that the black dotted line is cutting through the blue when the red is 0, and it's cutting through the red when the blue is 0. Well, not quite actually. Yeah, around about there. That's one way to do it. It's a bit of trial and error. The other way to do it is to actually try and calculate it, perhaps by using the blue and the red dots to help. And that might go something like this. Let's try and put the blue dot to represent this blue waveform here. You can see that the blue is leading the green by around about, well, that would have its maximum around about there. So I'd say that's about 90 plus 30, about 120 degrees leading the green. So if I go anti-clockwise from the green here, the blue will be somewhere in this direction, and its amplitude is about 3/4 of the amplitude of the green, so somewhere around about there would be a blue phasor that represents this blue waveform. The red one here is lagging the green at its maximum slightly after the maximum of the green, but not by much, maybe only by 10 degrees or so. So it is going to be 10 degrees clockwise of the green, and its amplitude is about the same as the blue, around about there. And then I'd say, okay, what happens if I add those two phasors together? And I add phasors just like you add vectors. You go along here, and then from this point you set off in the direction given by this phasor and for the distance given by the length of that phasor. So we would go down to the blue and then head off in the red direction for about the length of the red phasor, so that this line here from blue to grey is parallel to and the same length as this red phasor. And that would put my grey dot about there. And as a check, you could just check, well, if that's right, then it should have gone through the blue waveform when the red is 0, which it has, and through the red waveform when the blue is 0, which it has. And that's just confirmation that I've got these in the right place, and I've done the vector addition correctly. So that is my solution. Good. Next one. Another one here where we have the blue and the red waveforms, and we're being asked something about their sum, but this time it's not a case of dragging the black one to their sum. It's a case of answering what is the phase of the sum of them in radians. Well, again, the first stage is probably to find out what the sum is, and we could proceed by noting that the red is in phase with the green, but maybe half its amplitude. So I would put the red phasor around about there. And the blue is about 90 degrees lagging from the green, because it reaches its peak 1/4 of a period after the green reaches its peak. So that's 1/4 of 360 degrees, 90 degrees lagging. Lagging is clockwise because it happens after in time, so it's this way round. And in terms of amplitude, it's about 2.5, so we're maybe up there. So blue plus the red, add those two phasors together using vector addition, and we'd get a result around about there. We want to know what the phase is. Well, the phase of that is, I'd say, around about, say, 100, 115 degrees perhaps. But note that it's asking me for the result in radians, so 115 divided by 180 times pi should be close enough. And it is. Good. Right, see if we can find a different type. Here it's asking what the amplitude of the blue plus the red is. Well, the red now is about, say, 40 degrees or so leading the green, therefore anti-clockwise. It happens before it in time, so it's the same amplitude, so maybe somewhere around about there. Same amplitude as the green, so same length of phasor, about 40 degrees ahead, 40 degrees anti-clockwise. The blue is slightly closer to the phase of the green. Maybe that would be more accurate. And only about half the amplitude. So the blue phasor representing this blue waveform here would be around about there. Add the two together and we'd end up with something around about there. The amplitude of that, well, if that is 1, I would say this is somewhere around about 1.5. Very close. Good stuff. Here we've got to drag the black circle to represent blue minus red. Right. Well, blue minus red. If we look at the blue, it's leading the green, therefore anti-clockwise from the green by about, its maximum is there. I'd say that was around about 60 degrees or so. And its amplitude is around 3/4 or 2/3 of the green, somewhere around there, I think. The red one is leading the green, so anti-clockwise by not very much in terms of degree at all. Its maximum occurs there, the green maximum occurs here. That's not very much of a period. And in terms of amplitude, almost 3. So possibly somewhere around about there. Blue minus red would be then something like round about that kind of thing. Just looking at the phasor diagram. The blue and then minus the red, somewhere around there. And we can sort of check that by looking over here and seeing what this dotted black waveform looks like. When red is 0, it should be equal to blue. It's not exactly. Let's move it around in phase a bit. When red is 0, it's equal blue. That's a bit closer. And when blue is 0, it should be equal and opposite to red. When blue is 0, it should be equal and opposite to red. Well, red is about -2. It's not really big enough. Let's take it higher. That might be a bit closer. When blue is 0, it's now about +2 when red is -2. And when red is 0, it's equal to the blue. It cuts the blue there. So that's probably pretty close. Let's try it. Good enough. Actually, very close. Not bad at all. Right, that's level 2. I'll leave level 3 and level 4 for further videos or for you to work out.